Hello everyone, this video will show you how bottom-up tree transducers can be used to transform trees. Suppose we have a tree with internal S nodes and leaves of either A or B. We want to transform this tree so that the order of the children of each node is reversed, and each S is replaced with T. We'll go through how transducers can transform trees in ways like this. Tree transducers consist of four components. We have a set of states, Q. We have a set of input symbols, sigma, referring to the labels of the input tree. We have a set of output symbols, gamma, which refers to the labels of the output tree. We have a set of final states, qf, which is a subset of q, for the valid root states of the output tree. Lastly, we have our transitions, delta, which describe how to transform the input tree. Here's what a transducer that reverses trees like in our example looks like. We'll start with the input alphabet. The trees that we're transforming have the labels S, A, and B, so those will be the input. The output trees contain T, A, and B, so those will be the output alphabet. For the states of the output, we'll have a state QL for the leaves of A and B, and a state QT for our internal T nodes. We'll assume that T will always be the root, so the QT state will be our only final state. Here are our transitions. For our purposes, we'll represent them as a function taking in two things: a list of states of the child nodes in the output tree that we've built so far, and a symbol of the input node that we're processing now. The function returns both a state for the output tree and another tree, represented in bracket notation, that can contain variables for constructing the output tree. These first two rules are for reading the A's and B's in the input. The lists of child states in the input are empty because the nodes are leaves that have no children. The output state is QL, and the tree is labeled with the same symbol that we read and has no children. The next transition is for when we read an S with two children. The input has two QL states and an S label, meaning that this rule applies to an S that's the parent of two leaves. The state in the output is QT since this is an internal node. In the tree being returned, the node is T instead of repeating the input symbol like we did for A and B. This is how we can transform symbols. The next thing to note is that we have additional X variables in our tree. Each xi refers to the ith child in the list. Since we have x2, x1, the second subtree is first in the new tree, and the first subtree is second, reversing the order. The next rule is similar, but handles the case of a left leaf child and a right internal T node. Again, we'll replace the S with a T, and we swap the order of the children. The next two rules handle the other cases and work the same way. Each of these bottom-up rules builds the output tree up from the leaves by putting subtrees together based on those subtrees' states and the label of the parent of the children that were transformed into those subtrees. If this transducer were top-down, we would instead start at the root and add new children based on the input node's children. Let's see how this bottom-up transducer works visually. Here's the example tree from earlier. Since we're going bottom-up, when we process a node, we're going to look at the states of the children in the output and use the label of the input we just read in order to combine them and continue building the tree. Starting at the root, we don't yet have the list of output children to pass to the transition function, so we go to the left child. Again, we don't have the outputs, so we move on. Now that we're at the leaf, we know that there are no children and we can start building the output. According to our transition rule, when we have an A with no children, we output a tree with just A and the state QL. Now we can move on to the sister node. We have a similar rule outputting a B with state QL. Since we have the output states for the children of that lower S, we can now go back to compute its output. When we pass this list of states and the S to the transition function, we get the T tree containing the reversing variables along with the state QT. Everywhere in this tree we see x1, we replace it with the output of the first child of the node we pass to the transition function. Likewise, we replace x2 with the second child's output. This tree, with the variables filled, is the complete output of the subtree that we've processed so far. Now we can process that last leaf. We use the same transition rule we used for the other A to output another A leaf with state QL. Lastly, we go back to the root S. We can put the states of the outputs of its children into the transition function, and we can see that the output subtrees should again be reversed and have a T parent. Now that we've processed the entire tree, we check the output tree's root state. We know that this is a valid output tree because it is in the set of final states. That's how a bottom-up transducer works. We've seen how a bottom-up transducer is defined and how we can use them to perform transformations on trees. Thank you for watching.